which starts with angular bracket, then the name of the element, and it ends with the angular bracket. So this is student, and then the next line is about you define 3 tags within it. This is nothing but the content of student, and here you can see it's following the same strategy, or it is following the same structure. You have first name Henry, and it has closed the first name element. You can see the second element as last name, and which starts with angular bracket last name and end the angular brackets. Then there's actual value Lee, and you could see that it ends with a tag or with the element last name. So one thing to remember here is about start and ending of a tag, ending of an element. You can see that right after the value, the element is closed. And you can see nesting here as well. So student is a element, and you can see first name, class name, and email being nested into student element. Nested, or they are the child elements of the root element. So you have child elements defined here, and you have the last line which defines the end of the root element. Here we have a XML which has stores, or which is used to transport first name, last name, and email address of a student across systems. Let me show you the tree structure of this XML. So it could be imagined as student being the root element, and you can see that first name, last name, and email is nothing but your child, or is the child for student, since it's a root element. And you could see the values, the actual content of it. Within your first name tag, you saw the value Henry. Within the last name, you saw the value Lee. And within the email address, you saw henry123@gmail.com. So the leaf node is nothing but the content of elements, or the actual contents of the XML that you're trying to send across systems. This is pretty straightforward. Like, you could realize XML in a form of tree format, wherein your root node is nothing but element of your XML, and the leaf nodes or the leaves are nothing but the actual value stored in the XML. So let me talk about tree rules. In this given example, student is a root element, then first name, last name, and email are descendants of student. This is pretty much straightforward when it comes to tree. So you have a root node and you have descendants, and we can see from the structure. Ancestors, in this example, student is ancestor of all other elements. It's a root node, so it's an ancestor of all other elements within this tree. Now, what are XML attributes? You can have attributes which are common across, or you could have some attributes defined within an element. So here we can see that message, that's nothing but an XML with the root node messages, and you could see individual messages within. So there are 2 messages here within messages tag, and the first one is to Annie, and it's from John, and you have a body there, the actual body of the message, what you want to send. And you can see here there's ID, or there's something that has been provided as an attribute, which is nothing but, you could see MID is equal to 1. That's an attribute. It has to be enclosed within single quotes or double quotes. So whatever you see within the element enclosed within quotes, that is nothing but attribute. It's a modifier, you can say, some kind of a modifier to your element. So attributes add more information about the element. It is adding some more information to the element. XML attributes must always be quoted. Either it should be within single quote, or you could have it within double quotes. Here we have it within double quotes. What are XML comments? So to make it more readable, or to increase the maintainability of an XML so that someone else can understand what you're trying to do, you could have comments put in. So this is pretty much similar to comments in other languages. The reason why we rationale behind why we put the comments. It's more about make it much more verbose and understand what tag is all about. How we comment is nothing but, you have opening angular bracket, then you have exclamation mark, then 2 hyphens. And after the hyphen, you have the comment. And once you have the comment, you close it with double hyphen and then closing angular bracket. So one thing to note here is exclamation mark is there only when you start the comment, and at the end you don't have exclamation mark. It's double hyphen and then closing angular bracket. XML comments are just like HTML comments. Comments are used to make the code more understandable. What are the rules? Do not nest a comment inside the other comment. Okay, you can't nest it, and I don't see any need to nest it because we are just expressing it, or we are just adding comments to make it more readable. So if you nest it, it would give you an error. Do not use comments before an XML declaration. XML declaration should be the first line. You shouldn't be using comment before that. Comments can be used anywhere in XML file except attribute value. So you can't put comment within an element, or you can't put it right after the element is defined. Or say for example, you have this message tag, right, which starts with angular bracket and then message, and right after the message you can't have comment. Your element tag has to be closed. After this closing angular bracket, you could put any comment, but it cannot be within this space wherein you define the attribute. So basically comment can be put anywhere, but it cannot be as attribute value. So let's see a well-formed XML, and what do we call well-formed XML as? There must be exactly one root element. An XML should have exactly one root element. You cannot have multiple. Every start tag has a matched end tag. So we saw in the previous example, like if you start student, you have to ensure have an end tag for student as well. So that's what it is about. Every start tag must have an end tag. Attribute must be quoted either with single quotes or you could have double quotes. Comments and processing instructions may not appear inside a tag, cannot be inside a tag, and you have opening angular brackets or and must not occur inside a data element. Your data cannot have this as value, or your data element cannot contain this as a part of the name of element. So let's move towards XML validation. So well-formed XML can be validated against DTD or XSD. The communication between multiple systems. You have to ensure client is sending data or is kind of, preparing an XML which is aligned to what server expects, right? So that's where you have DTD and XSD. Let's see what is DTD. DTD is a eBNF grammar defining XML structure. It's a normalized format grammar which defines XML structure. A DTD defines a legal element of an XML document. So it says what XML can contain, what an element could be, or what the attributes could be. And it's a legal element. Okay, so basically, when you define a DTD, you can expose a service today which could be used by Google tomorrow, right? Google can be using it for some purpose. So, this is a legal document saying that my service expects or accepts data in so and so format. So, you have to send it in so and so format for us to process it through. All right, so it's a legal document between multiple organizations. XSD is nothing but used to address the shortcomings of DTD, uses namespace to allow for reuses of existing definitions. So you could define an XSD and you could just use it, or through namespacing, you can have it within other pieces of XMLs as well. So let's see what is DTD. DTD stands for Document Type Definition. DTD is used to define structure of an XML document. A DTD defines the legal elements of an XML document. As we spoke, it defines legal elements or which cannot be accepted. So basically, you define what your XML is all about through DTD. So you could see a student DTD here. So you have XML, which is nothing but which has student, which has first name, last name, email, and marks. All right, this is what you have within your XML. Now you define a DTD, which could be put into your doc type. So the first tag that you see is nothing but declaration, and it's linking, you're kind of tying it against a DTD that's defined, external DTD file. All right. You define this and you have a DTD file below, which is student.dtd. And here you can see that it says that within student element, you can have four other elements, or there's a nesting of four other elements, which is first name, last name, email, and marks. All right. If you, since this DTD is linked with your document or with your XML document, now if you try to add something, if you have one more element here, which could be like address, right? If you have one more element here, which is address, it would throw you an error because your DTD says that student can have only first name, last name, email, and marks. Address is not a valid element within student. All right. First name. Now let's define what can we have in first name. All right. So first name is nothing but character data. Again, last name is a character data. Email is again a string, and marks is again taken as character sort of. So this is how we define DTD. All right. So we are trying to establish the structure, or we are trying to say that student can have only so and so fields, and if there's something else, then it's invalid. So here we can see DTD contains a root element and declare the child elements. We can see here that it says student can have only first name, last name, and email and marks. It defines last name, child, element, and data from this element is parsable. All right. When it says PC data, it's parsable. Again, you have first name, which is parsable. You have last name, which is parsable. You have email address, which is parsable, and you have marks, which is parsable. All right. So what is XML schema? XML schema is used to express constraints about XML document. All right. It's pretty much, it does the same purpose as DTD, but it's much more advanced than DTD. It has much more features. XML provides more control on XML structure. A well-formed XML document can be validated against XSD. So you have an XSD again similar to DTD, which defines the structure, and a well-formed XML should be validated or should be valid against a particular XSD. So here we see an XSD which is much more verbose, or which is much more clearer to understand compared to DTD. DTD was something like, it was not expressing to that extent, but XSD is pretty clear in terms of what the content could be. Again, it defines the root node and declares the child elements. So here you can see that XSD is defined in a form of XML itself. All right, it follows the same pattern as the XML. So it says element, which is a keyword. All right, element is a keyword for your XSD, and you have student as an attribute. So this, you could realize XSD, as I said, as an XML itself. It's a valid XML rather, which says that you have an element with name student. Now what can student hold is again a sequence. When you say sequence, it has to be in the same sequence. Break the sequence, it's again going to be invalid. Then it says first element, first child element within student should be first name. The next one to follow should be last name. The next one should be email, and the last one should be marks. All right, and it defines what type this particular elements hold. So first name is a string, last name is a string, email is a string, and marks is a string as well. So this is how it is. You define a structure to the XML, and you have to ensure for your XML to be valid, it has to be valid against this XSD. It's just XML schema descriptor. So what's the difference between DTD and XSD? DTD stands for document type definition. XSD stands for XML schema definition. DTD is not extensible. XSD is extensible. DTD provides less control on XML structure. XSD provides more control on XML structure. DTD does not support data types. XSD supports data type. We saw the data types like string and stuff, which is like it's supported just in XSD. You don't have DTD supporting it. DTD does not define the order of child elements. As we could see, it just says that you could have 4 elements within, but it doesn't have any specific order as such. Whereas when it comes to XSD, you could define a sequence, right? As we saw in the previous example, we said that the first one should be the first name, then the last name, then email ID, and then marks. So you could define the sequence in which your sub elements should occur. XML CSS file. CSS is used to add more styles to the XML document. So if you want to color code it or do something, that's when you use CSS, pretty much similar to HTML document. So here we can see that you could define student, which has got a background color of pink. Then you have first name, which has different font sizes here, first name, last name, and email ID, and marks, which has got different font sizes. So we want to have font size of 25 for this child elements. We want to display it as a block, and color as white, and the margin left as 50 pixels. All right. When you have such thing defined, if you want to link it up, or if you want to link CSS to a XML, you need to have a XML style sheet tag defined, and you put type as text or CSS, and you put href as your CSS name. To make the changes in the styles of the XML file, CSS file is linked to XML file through this statement. So this is how you link your CSS file to your XML file. Now, what is XSL? XSL stands for Extensible Style Sheet Language. XSL navigates all the nodes and elements and display XML data in a particular format. All right, it's basically for parsing sort of. It navigates through all the nodes and elements. Queries can be specified in XSL. If you want to query some particular data, like we had message, this thing in a couple of slides back, we saw multiple messages within message, right? So if you want to read some messages, extract the messages that are sent by the users, you could query it out using XSL. It displays data on the browser as per the format given in the XSL file. So let's see what is XSL file all about. Okay, so here what you're doing is nothing but you're extracting data. All right, you're extracting first name. So the first name here would be taken from your student and would be displayed here. And again, the second one, you have last name. You select the last name. Particularly, this is acting upon student.xml. All right. How do you link up XSL to XML is pretty much similar to CSS. You have style sheet and you have type as text slash XSL and not CSS, right? And you have href as student.xsl. So that's for XSL. And again, let's see what's the difference between CSS and XSL file. CSS files are easy to understand. XSL files are difficult to understand. CSS is less powerful than XSL. CSS is specifically for display, right? Changing the font size, changing the colors, background colors, and foreground color, and everything. XSL is more powerful than CSS since you can extract data or do something with it. Basically, it's a processor. You actually can process the XMLs using XSL. CSS does not use XML notations. XSL uses XML notations, which helps in writing code. CSS can be read by modern web browsers. XSL is not supported by many web browsers. Now let's talk about XML parsers. Okay, so XML parser is nothing but you parse through, you have an XML and you want to read data from it, or XML parsers could be used for writing the XML as well. Okay, creating an XML could create an XML using XML parsers as well, or you could read through the existing XMLs. So an XML parser is a software library which provides client applications to work with XML document. An XML parser is used to check whether the document is in well format or not. It is basically used for compiling or parsing your XML as well. It is used to validate an XML document. And parsing XML refers to going through XML document to access data or to modify data in one or the other way. All right. You could actually read through the XMLs, or you could extract data, or you could modify data using XML parsers. What are parsers? Here you could see XML document, right, being sent to the parser. Parser is nothing but API. So you send the XML, the source XML or the XML that you're trying to parse is going to be sent to the XML parser. And this API is going to be used by client application, right, to parse the XMLs. So XML parsing could be broadly classified into two different types. One is object based and one is event based. All right. Object based is nothing but document object model, or it is also known as DOM. Event based, we have two different parsers when it comes to event based. One is SAX and the other one is STAX. All right, so let's talk about object based model. DOM parser, it stands for document object model. It is an object oriented representation of an XML parse tree. So remember, we saw an XML and we parsed it into a tree like structure wherein your root node of the tree was the root element from your XML, and we had all the elements, and at the end the leaves were nothing but the values or the data that the XML stores, actual values, right? Or XML stores or carries rather. So that's what tree is all about. It defines the standard way to access and manipulate documents. DOM is a common way for traversing the tree. So as we look through the examples, you should get fair idea about it. Creating an XML document using DOM parser. So what is required to use DOM parsers? How do we do that? First is you have to import all the parsers. You have to import all the classes that you have within javax.xml.parsers. These are all import statements that you have. You have to import different packages, which when you use IntelliJ or Eclipse, it would prompt you to import it. It would suggest you to import it. So you did not actually write these import statements, but it's very important to understand what we are trying to do here. So these are different packages that we are trying to import. And as you could see, all your XML related classes are put into javax.xml.transform, or basically javax.xml package. So once you import it, you can start using the classes within. The first thing that you do is when you generate an XML, you have document builder factory. So you have document builder factory.new instance. You create a new instance of it, and you get document builder factory, that's the instance of it. So now with the document builder factory instance that you got, you would create a new document builder. Okay, so this is a factory design pattern. We have a design pattern in Java, and document builder factory is nothing but it's following a factory design pattern. Right, you don't have to think much about it, but basically what we are trying to do is instead of creating the instance of something on our own, which is like we usually do with new and the class name, right? Instead of doing it on our own, factory design pattern is nothing but the creation logic is written within a class which is not exposed to you. So you need not create it. There's some class which creates instance for you. All right, and that is nothing but a factory class. Then you create a document builder. So it's nothing but f.new document builder. Okay, you handle the exceptions and everything here. So now let's start with creating the actual document. You have the root element as students, all right? And within student, you have student. Within students, you create student, and within student, you have like first name, last name, email, and marks. And you could see first name put as Henry. So how do you create element is nothing but using doc.create element. How do you create text node or the actual value that you have within your element? You would do it with create text node. And you could nest it using append child. So basically you have first name appended to T1, which is nothing but this one, right? T1 is appended to the first name element that you have. T2, which is the text node, which is holding the last name, is appended to the last name element. T3 is appended to email element, and T4, which is your marks, is appended to marks element. So basically, this is how you make nesting of your nesting within the XMLs. All right, so once you create this document, you append all the childs and everything. You create a well-formed document here, or you create an XML here, and all the XML that you would get is within this doc. Since we are creating element, you could see here, we are creating elements within doc, creating elements and text node and everything within doc. So at the end, once you have all this done, you would have a well-defined XML stored as a form of document class. So we want to print this particular document in a text format, right, which could be readable by us, or we want an XML out of it. So that's when we use transformer. So there's a transform factory dot, again, since it's a factory design pattern, it's exposing a method which is nothing but new instance. So you create a new instance of transformer factory and you create a new transformer. So then what you get is nothing but a transformer. And what are we trying to transform is nothing but we are trying to transform the object or the document object that we created. We are trying to transform it into a human readable text file or the XML file. All right. So that's a transformation that we are trying to do here. So here you could see that you transform it, t.transform, and you pass the document object that you created and put the element into element and text nodes and everything into, which is holding a valid XML. You're trying to transform it into an XML file. So how you do that is t.transform. Then you have the new DOM source and you specify the instance of document which holds your XML. Then you have stream result and new stream result class, which takes file output stream as its parameter. So you have to pass the parameter where you want to write this XML to. And when you run this, at the end, we are just printing that XML file is being generated. The first thing that we do is we are creating a document, and using the document, we are creating elements the way that we want. So in this case, we have a students as a root node, and within students, you have student, and within student, you have first name, last name, email ID, and marks, right? We created the structure till here. And as you could imagine, this is just dealt in the form of object, right? Which is stored in doc. So now, since you want to write it into a file, which is into a human readable form, or which could be passed across network, you have to transform this into a XML file, which could be read. So that's what we do here. Through transformer, we are transforming your document or the XML, which is in the form of document, into a file. So let's see this program. So in the meanwhile, we can do one thing. I'll create one more directory here, Edureka XML. Okay, and we don't have any files within. Yeah, let's hold on for a minute. Yeah, it has come up. All right. So it's the same program that we spoke about. So I have loaded into my IDE. So we do the same steps here. We create all the elements, all the required elements and stuff. So we are writing it into a file, right? So you could have your own file here, whatever file you want to write into. Okay, so I write it into the directory that we created, which is nothing but Edureka XML. And we are writing the XML file there. All right, so let me execute this program. It's building it. And if it's generated, you should get XML file generated at the end. So this is about using DOM. All right. So when you say DOM, it's nothing but document object model. It's building yet. So hold on for a minute. Okay, let's see. I think it should come up soon. Right. I think it's coming up. All right, so we have this program here, which is kind of creating XML document. This is same as what we spoke in the slide, right? What I walked you through. So basically you have students, you are creating students elements. Within students element, you are going to have student and then first name, last name, email, and marks. All right. We are going to create a text node within this elements. So this is nothing but your first name, which would go into the first name element. This is the last name, which would go into the last name element that we created earlier. Then we have